So today we are continuing our conversation on probability and jumping into an idea called sample space. And so first we need to define exactly what a sample space is. This is one of the vocab words on your vocab sheet for the unit. A sample space is simply an arrangement of all of the possible outcomes for an event. So an arrangement of all possible outcomes for an event. So really we've already kind of explored this. When we started probability, I gave you a few scenarios and asked you to list all of the possible outcomes. That's really what a sample space is. We're just going to talk about a couple different ways today on how to organize them once our events start getting more and more complicated. So the first example that I have there on your notes is you flip two coins. What are the possible outcomes? And when we first started listing sample spaces, we just listed them in a list. And so if you were just flipping one coin, you could write a list, and I'm just going to do this over here, and list them that your options are getting either heads or tails. Really, that's a sample space already. You're creating a list of all of the possible outcomes for the event. But in this case, you're flipping two coins. So that means you're going to flip one coin two different times, and they want a list of all of the possible outcomes. So one of the strategies to organize these thoughts, that way we know that we don't miss any, is to make a table. And so what you'll do is you'll create a list of all the possible outcomes for your first try. So we know when we flip a coin, we have the option of getting heads, or we could get tails. But then we're going to flip it another time. And so on our second try, we're going to make a table. So we're going to put this down the side here. On our second flip, we have the options of getting heads or tails. And so we just list the first trial across the top and the second down the side. And then what we do is we make just an arrangement on the inside. It almost kind of looks like a multiplication table once we're done, because you're taking what's up here on top and what's here and creating a list. So one possible outcome is that you could flip heads the first time and then heads the second time. And see, I'm just pulling from both sides here. Another option would be to pull tails the first time, or flip tails the first time, and I'm starting up on my top row, and then coming and flipping heads the second time. As I continue the pattern, I could flip heads the first time and tails the second time. And then lastly, I could flip tails the first time and then tails the second time. So we see that there are 4 possible outcomes for this event. And there is our list right there. You could get heads twice, you could get tails twice, you could get tails first and then heads, or heads first and then tails. So we're just going to walk through a couple examples, just practicing organizing our thoughts. So the next example down the page is you are playing a board game that requires you to spin a spinner that's labeled 1 through 5, and then roll a die. You want to know all the possible outcomes, so we're going to make a table. So again, our first step is going to be to start with whatever the first event is. In this case, we're spinning a spinner. So I'm going to create a list across the top of my page of the possible outcomes. So on event number 1, we could spin a 1, we could spin a 2, we could spin a 3, we could spin a 4, or we could spin a 5. After we spin our spinner, we have to roll a die, and so we list those events going down the side. That is event number 2. So when we roll a die, we could roll a 1, we could roll a 2, we could roll a 3, a 4, a 5, and then a 6. And I'm actually going to label my table just so that I know what each of these groupings of numbers means. And so the top, I'm just going to write that this is the spinner, and over here on the side, this is the die, just so that I know where I'm pulling the numbers from. And then again, we just fill in the inside with all of the different possibilities, starting with whatever the event is, the first event is first. The order does matter, so always make sure that you're pulling just consistently from the same side. So I'm going to start with the top. I could spin a 1 and then roll a 1. I could spin a 2 and then roll a 1. I could spin a 3 and then roll a 1. A 4 and then roll a 1. A 5 and then roll a 1. And so those are my options when I roll a 1 with each of the different spinners. So I'm going to continue the pattern just as I keep going. I could spin a 1 and then roll a 2 and then 2, and hopefully you're seeing the pattern as we go across, just pulling numbers from both sides. So take a minute, fill in the rest of this table, and we'll come back and make sure that we both are on the same page. So hopefully you've finished your table and it's filled in and looks very similar to mine. You now might be asked a series of questions about a table such as this. And the first question that you'll probably almost always be asked is, how many different outcomes are there? And in order to determine that, we need to make sure that we are focused and looking on just the inside pieces, because those are all of the possible outcomes that we listed. The outside numbers are just the specific events individual of each other. It's the inside that is the list of all of the events. So we see here that this table is a 5 by 6 table. And so there are 30 possible outcomes. Maybe you just picked up on a little shortcut, and there's actually a name for that shortcut called the counting principle, that if you have different events, you can multiply the amount of possibilities for each event together to get the answer of the total amount of outcomes. So there's 30 possible outcomes here in this event. You could also be asked questions specifically about the probability of a specific roll or spin happening. So for example, you could ask, what's the probability of you rolling a 3? And so then you would take your table of all of the possible outcomes and look for any time that a 3 was rolled. And I'm looking right in here on the inside. I see this whole row all has a 3 that was rolled on the die. So there's 5 different outcomes that a 3 was rolled on the die. And so you could be asked a lot of different questions after you've made a table of all of these events. One other way to organize your thoughts, though, that's different than a table, in most cases you'll have the opportunity to choose how you want to arrange them, is what we call a tree diagram. So we're going to look at our next example, and this time, instead of a table, build a tree diagram. So this is on the back of your notes. Problem number 2 is that in your closet you have 3 pairs of jeans and 4 sweaters. What are all the different possible outcomes of outfits that you could wear today? So a tree diagram ends up when you're all done, there's lots of different branches that all connect to each other. So we're going to start, and you can always choose where to start, but I like to usually start with the actually the bigger number, because then my tree gets smaller and smaller as we go. So I'm actually going to start with the 4 sweaters that I have, and really you're just going to list, I'm going to use the letter S to talk about sweater and call it sweater 1, sweater 2, sweater 3, and sweater 4. And so we start, and whatever it is, you can abbreviate your own system. But then off of each sweater comes each pair of jeans, because I could wear sweater 1 with pair of jeans number 1, 2, or 3. So off of this sweater, I'm going to have 3 different branches for my 3 pairs of jeans. I have jean 1, jean 2, and jean 3. But those 3 jean options work for any of the sweaters that I wear. So I have jean 1, jean 2, and jean 3 for sweater number 2, for sweater number 3, and for sweater number 4. Jean 2, jean 3, jean 1, jean 2, and jean 3. And so you could be asked now also what all of the total number of outcomes. That was the original question. How many different outfit options are there? And the quickest way with a tree diagram to determine this is to look at that final branch. So in this case, it's looking down here at all of the different gene outfits that you have and counting that final branch that we have created. So in this case, we have 12 different outcomes. And you notice that multiplication trick works here too, because 3 times 4 gives us 12. So there's 12 outfits possible in this tree diagram. You could also be asked what the probability is of you wearing sweater number 2, in which case you would look at the 3 options here that you wear sweater number 2, and so it would be 3 out of the 12 different outfits, or 1/4 of the outfits. So a follow-up question to this that you see down there at the bottom, and I'm going to undo what I just drew for the purpose of adding to this tree diagram. The follow-up question says you also have 2 scarves in your closet. So add these to your diagram and determine the new total of outfits that you have. So we're going to add another branch here to our tree diagram. We could wear scarf number 1 or 2 with any of these outfits. So those scarf options, those 2 scarves, have to come off of each of these gene options that we now have. So now I have scarf 1, scarf 2. I could wear scarf 1, scarf 2 here and here. So continue filling out all of these branches now, but adding your scarf options. You'll probably start to notice that these tree diagrams get a little messy. They get a little complicated. So if you don't have a lot of room, it's nice to start on just a larger piece of paper or a surface, because depending on the amount of events taking place, this could take up a lot of space. So I'm just about done here. I've listed all of my scarves off of all of these different gene options, and notice that we just really increased the amount of outfit choices that we have. A simple problem like this really does have a lot of different outcomes. And so if you now want to determine the total amount of outcomes you have, again, we're looking at this bottom branch where all of these scarves are listed and counting them all up to determine all of the possible outfits. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. We now have 24 outfit combinations because we added those 2 scarves into the mix. And again, our counting principle, which is what lets us just multiply, would work in this scenario too. If you take your 4 sweaters times your 3 pairs of jeans times your 2 scarves, you also get 24 outfits here as well. So if you're not asked to make a diagram, you could always use this counting principle instead. So that's it. That's our 2 different ways to create sample space. You now have a problem set or a couple practice problems where I want to see if you can take these table ideas and tree diagrams and make some sample spaces of your own. So come show me the notes and I will give you your assignment for the rest of the class period, and if you don't finish, it turns into your homework.